Welcome to the mathematics of my channel. In this video we are going to solve this nice integral from 0 to 1 x minus 1 over x plus 1 times natural log of x dx. This question suggested me the Brazilian professor Paulo Sergio Lino. If you interest, visit Math Facts YouTube channel, Professor Paulo Sergio Lino's channel. Okay, how to begin? Well, first I am going to define an integral. I of a is equal to integral from 0 to 1 x to the a minus 1 over x plus 1 times natural log of x dx. Okay, then I am going to differentiate with respect to a. So here we know I dash of a is equal to integral from 0 to 1. Now x to the a, derivative of x to the a with respect to a, we know x to the a minus 1 constant times natural log of x over x plus 1 times natural log of x dx. Now we know natural log of x get cancelled, so we have I dash of a is equal to integral from 0 to 1 x to the a over x plus 1 dx. Well, I use the solution of this integral I didn't remember the video, but a couple of weeks ago I used the solution of this integral without any proof. I thought I publish the solution of this integral, but I didn't. So in this video we will evaluate this integral. Okay, so I am going to take integral j is equal to integral from 0 to 1. Now here we have a, but I am going to take here s minus 1, so we can arrange later. So here 1 plus x dx. Okay, then here in the denominator we have 1 plus x, so I am going to take 1 over 1 plus x, we can write 1 minus x, and now we can write this is by using infinite sum. N is equal 1 to infinity, n is equal 1 to infinity minus 1 to the n minus 1 times x to the n minus 1. So now we can plug in here, so we can write integral from 0 to 1 infinite sum n is equal 1 to infinity minus 1 to the n minus 1 times x to the n minus 1, but here we have x to the s minus 1, so sum of s minus 1 and n minus 1, we know x to the s plus n minus 2 dx. Okay, then we can change the order of summation and integration, so we can write here n is equal 1 to infinity minus 1 to the n minus 1 power integral from 0 to 1 x to the s plus n minus 2 dx. Then we can integrate this, so here we have n is equal 1 to infinity minus 1 to the n minus 1. Here if we integrate, we know x to the s plus n minus 1 over s plus n minus 1, limit from 0 to 1. Okay, then we know this is j. Now j is equal to, here we can apply boundaries, so if we apply 1, we have s plus n minus 1. So infinite sum n is equal 1 to infinity minus 1 to the n minus 1 over s plus n minus 1. Okay, then now we can rearrange the sum considering even and odd n. So we will have here 1 over s plus 1 over s plus 2n minus 1 minus 1 over s plus 2n minus sorry, here 2 and here 2n plus s minus 1. Okay, then I am going to add and subtract 1 over 2n, so we can write 1 to infinity here 1 over 2 times n, then I am going to take this part, so minus 1 over 2n plus s minus 1, then here we add 1 over 2n, so we should subtract 1 over 2 times n, and then here plus, so here minus, so here also minus 1 over 2n plus s minus 2. Okay, then now I'm going to take this 2 as a common factor, so we can write 1 over 2 infinite sum n is equal 1 to infinity. Now here we have 1 over n minus, here we have n plus s minus 1 over 2 s minus 1 over 2, then here again minus 1 half infinite sum n is equal 1 to infinity 1 over n minus 1 over n plus s minus 2 over 2. Okay, then I am going to reindex, so here 1 half. Now instead of 1 I am going to take 0 to infinity, so we know this n will be n plus 1, so 1 over n plus 1 minus 1 over plus 1, so plus 2 minus 1, so plus 1, so n plus s plus 1 over 2, then here also n is equal 1 to infinity 1 over n plus 1 minus 1 over plus 2 minus 2 get cancelled, so n plus s over 2. Okay, now we know the definition of digamma function. Digamma of x is equal to minus gamma we know Euler's Mascheroni constant plus infinite sum n is equal 0 to infinity 1 over n plus 1 minus 1 over n plus x. Okay, this is the definition of digamma function. Now we can write j is equal to, now here 1 half, here 1 half, 1 half is a common factor, and now instead of this part we can write now x is equal to s plus 1 over 2, so but here minus gamma, so plus gamma plus digamma of, now x we know s plus 1 over 2, so s plus 1 over 2, then here minus again here gamma plus digamma of, now x we know s over 2, so s over 2. Now we know gamma minus gamma get cancelled, so we have j is equal to 1 half digamma of s plus 1 over 2 minus digamma of s over 2. Okay, this is the answer of this integral x to the s minus 1 over 1 plus x, very important integral. So then let's take I dash of a. We know I dash of a is equal to x to the a over x plus 1. So I'm going to write here I dash of a is equal to 0 to 1 x to the a over 1 plus x dx. Okay, then we can rearrange our integral like j, so we can write this is equal to 0 to 1 x to the a plus 1 a plus 1 minus 1 over 1 plus x dx. Okay, then we know s is equal to a plus 1, so we can write I dash of a is equal to now 1 half digamma of s plus 1 over 2. Now s we know a plus 1, so a plus 1 plus 1 a plus 2 over 2, so digamma of a plus 2 over 2 minus digamma of s over 2. S we know a plus 1, so a plus 1 over 2. Okay, then this is I dash of a. So now we can integrate. So if we integrate, here we have I of a is equal to 1 half. Now integration of digamma function, we know the derivative of natural log of gamma of x is equal to digamma of x. So now we can use antiderivative, so we can write here 1 half here. Now natural log of gamma of a plus 2 over 2, but when integrating we should divide by the coefficient of the variable. So here 1 half, so we should divide by 1 half. It's mean we should multiply by 2, same as here 2 times natural log of gamma of a plus 1 over 2. Okay, now we know these two get cancelled, so we have I of here I forgot the constant, so we should find the constant. So if we plug in 0 to I of a, we know I of a is equal to integral from 0 to 1 x to the a minus 1 over x plus 1 natural log of x dx. So if we found I of 0, we know here 1 minus 1, so we know 0. So I of 0 is equal to 0, and here now if we plug in 0 here, we know here gamma of 1 we know 1, natural log of 1 we know 0, so here minus, so minus natural log of gamma of a is equal 0, so here 1 half plus c, so c is equal to natural log of gamma of 1 half. Now we need I of 1, this is IA, so if we take I of 1, we know we have 0 to 1 x to the 1, so x minus 1 over x plus 1 times natural log of x dx, and we know now this is equal to I of 1 natural log of gamma of 1 plus 2, so 3 over 2, then minus natural log of gamma of 2 over 2 we know 1, so this part we know 0. Okay, gamma of 1 plus c we know natural log of gamma of 1 half. Okay, this part we know 0, so we have natural log of gamma of 3 over 2 plus gamma of 1 half. According to property of natural log, we can write gamma of 3 over 2 gamma of 1 half. Now gamma of 3 over 2 we know is square root of pi over 2, gamma of 1 half we know is square root of pi, so we have natural log of pi over 2. Okay, this is the answer for this integral. Thank you for watching.